Hello M1, it's Mr. Chiu again. So how are you? Are you now enjoying your time during the school suspension? I know that many of you are not. In the last 2 months, I spent so much time in doing nothing. I watch YouTube videos, Netflix videos during the daytime, and sometimes I even go outside to the empty shopping mall and countryside. So even though that I spend so much time doing these things that I don't usually do during the weekdays, but I don't enjoy. Instead, I feel so guilty. I cannot sleep well at night. Most of the time I have nightmares. And after that, I try to change, and I fix myself a schedule. I prioritize all the things that I need to do first. So every day I come back to school and fix all the things that first. And then even though that I have less free time, I just watch a few episodes of Netflix or YouTube at night. But I find that I enjoy, I can maximize the happiness. I don't feel guilty anymore. So I would like to remind you and tell you that self-discipline is very important. If you want to maximize your happiness, enjoy your life, make the most of your life, you should be more self-disciplined. Okay? I've been so struggling whether I should continue to make the video because I've just seen that there are only 3 views in the last video. Now, but I trust you, you are the elite students in this school. So, please, enjoy your life, okay? Be more self-disciplined. Do the schoolwork first so that you could enjoy most of your free time. All right? Now let's continue. Today is gonna be something important now. Last time, so we've started chapter 12, discrete probability distribution. And there are 4 different things that we have to learn. The first one is Bernoulli distribution. And then we know that for Bernoulli distribution, when something random variable follows a Bernoulli distribution with the probability of success p, then we could find mean and variance by using these 2 formula. Mean is just p, and variance is p times 1 minus p. So this is what we've learned last time. And today, we go to the next one, a binomial distribution. And then next will be the geometric distribution, and the last one is Poisson distribution. Oh, not enough battery. Okay, so let's make it quick. So today, let's look at the binomial distribution. But before that, let's recall the Bernoulli-Chow, the event, Bernoulli event. Do you remember what is a Bernoulli event? So please tell me which of them is a Bernoulli event. So first of all, Vicky submit M1 homework on time. Do you think that it is Bernoulli-Chow, Bernoulli event? The second one, Alex passes the M1 quiz. And then Wasim watched the M1 lesson video. James is now enjoying the school suspension. So which do you think that is a Bernoulli-Chow? It depends on the result. For the first one, Vicky submit homework on time. So it could be yes, she does, or no, she doesn't. Alex passes the M1 quiz. It could be yes, he passed, or no, he failed. Wasim watched the YouTube video. The results could be yes, he watched, or no, he didn't watch. Or the last one, James enjoyed the school suspension. Yes, he enjoys, or no, he doesn't enjoy. So when the result could be either two possibility. Yes or no, true or false. These are the Bernoulli child. So these are all Bernoulli child. Okay? And last time we talked about a very classic example, toss a coin. When you toss a coin, so there could be only two results, head or tail. This is what we did last time. Let a random variable x be the number of head obtained when you toss a coin, and the probability of getting a head, the probability of success is 1/3. Then we say that x, this random variable, follows a Bernoulli child with the probability of success 1/3. So what could x be? X could only be 0 or 1. So 1 means success, getting a head. 0 means fail, getting no head. Okay, so this is a Bernoulli distribution. And now, let's extend this idea. And today we are not looking at just one Bernoulli child, but what if there are more than one Bernoulli child? We toss a coin, and then we toss the coin one more time, we toss the coin one more time, and we toss it one more time. So altogether, we totally toss a coin 4 times. So when we toss a coin 4 times, and now what do we concern? We want to know that, yes, we still want to get a head. Head means success. How many times could we get a head? So this time we concern, let the random variable x be the number of head obtained among the 4 childs. When you repeat these things 4 times, how many times that you could get a head? This is what we concern. This is the random variable. So we do not just do one time, but we perform more than 1 times. We call this distribution a binomial distribution. So we say the random variable x follows not Bernoulli distribution, but binomial distribution. And then there are 2 parameters, 4 and 1/3. Guess what? What does it mean by 4? 4 means how many times that you repeat this experiment, this event. In this case, we repeat this event, toss a coin 4 times. And for each of the time, the probability of getting a head, the probability of success is 1/3. So we need these 2 information in this distribution. So this is the format. For BIN means binomial, abbreviation, short form, binomial distribution. And we need N and P. N is the number of times that you repeat the events, and P is the probability of success. Okay? Then I have a question. What could X be? Number of heads. Could it be 0? So you repeat this 4 times. Is it possible that none of them give you a head? Yes. So X could be 0, and X could be 1, 2, 3, or 4, but cannot be more than 4. You toss a coin 4 times, you cannot get 5 heads. You can at most get 4 heads, or at least get 0 head, right? So these are the values of X. And now let's consider one more. So last time we have this example, the gender of a baby. Someone is going to give birth to a baby. So the gender of the baby could be a boy or girl. And you want to have a baby girl, so let X be the number of baby girl obtained. And the probability for getting a baby girl is 1/4. So that X follows a Bernoulli distribution because you just do this experiment 1 time, and the results could only be boy or girl, so that this is Bernoulli. So X follows Bernoulli distribution. The probability of success getting a baby girl is 1/4. X could be 0 or 1. X equals to 1 means that you can get 1 baby girl. X equals to 0 means that you can get no 0 baby girl. Okay, X could be only be 0 or 1. But now, what if we extend this idea? So you are going to give birth to 5 babies. Someone is going to give birth to 5 babies, 1, 2, 3, 4, 5. And for each of the baby, he or she could be a boy or girl, okay? And you wonder, okay, these 5 babies, how many baby girls could I have? You let X be the number of baby girls obtained among these 5 childs. So you want to have a baby girl. So baby girl is defined as success. X is the number of baby girls for among these 5 human beings, 5 babies. So then we know that X follows a binomial distribution. So binomial distribution. Number of times of the event, experiment, trials is 5. And for each of them to be success, the probability is 1/4. Okay? Now, what could X be in this case? Can you tell me what could X be? X could be 0, 1, 2, 3, 4, or 5. You could have 0 baby girl, 1 baby girl, 2 baby girl, 3, 4, up to 5 baby girls, but cannot be getting more than 5 baby girls because you have 5 babies only. You could never have 6 baby girls. Okay, so these are the number of success obtained among 5 childs. All right. Now, let's go to here. So let's look at this example. Let X be the number of times that Vicky hand in the M1 homework on time amongst 5 different homeworks. So in the coming 5 homeworks, how many times that Vicky will hand in on time? What do you think? So first of all, we need the probability of success. So for each of the homework, Vicky can hand in on time. What is that probability? What do you think? Okay, let it be P. Let the probability that Vicky hand in the M1 homework on time is P. Okay, and then we are going to look at 5 homeworks. So we wonder how many times that Vicky can hand in on time, how many times success. So we know that X follows a binomial distribution. We are going to repeat this experiment 5 times, and for each of the time, the probability of success handing on time is P. All right? Then how to get this probability of X equal to 3? How to find this probability? 3 times handing on time. Are you able to find this probability? Okay, first of all, you may consider, oh, I want 3 times, so the probability that she can hand it on time is P, so P 1 time, P the 2nd time, P the 3rd time, and then the 4th time and the 5th time are failure, cannot hand it on time. So if the probability that she can hand it on time is P, then cannot hand it on time must be 1 minus P. So we times 1 minus P times 1 minus P. Okay? And then what about, is there any other combination? So what about the 3rd time and the last time she cannot hand it on time, but the 1st, 2nd, and 4th time she can hand it on time. So you know that there could be many different arrangements. So if you find all different arrangements, okay, these are all different arrangements. So how many different arrangements are there? Is there any shortcut to find the total number of different arrangements? There are 5 different items, 5 items, 3 of them are the same, or 2 of them are the same. We could use NCR, right? So you could use just 5C3 to find how many different arrangements are there. 5 items with 3 of them in the same group or 2 of them in the same group. Oh, there are 10. There are 10 different number of ways to arrange them. Therefore, if you want to find X equal to 3, then you could put it this way. 5C3, that means 10, times probability of success 3 times, probability of failure 5 minus 3, 2 times. Okay? So this is the shortcut to find this probability. And then if you have to find, what about X equal to 5? All the 5 times she could hand in on time. What is that probability? Using the same idea. 5C5, and then probability of success 5 times, probability of failure 0 times. Probability that X equal to 0. or the 5 times she cannot hand in on time. What is that probability? You may use 5C 0, and then probability of success 0, probability of failure 5 times. Okay? So we call this the binomial formula. You could use the formula to help you to find the probability. And now, let's look at a general case. So let's go back to tossing a coin. So let X be the number of times getting ahead. You want to get ahead. Head means success. When you toss a coin 4 times, so let it be a fair coin so that the probability for getting ahead when you toss a coin is 0.5. It is a fair coin. So you're going to toss the coin 4 times, and obviously X follows a binomial distribution. So you are going to do this experiment 4 times, and for each of the time getting ahead, success is 0.5. So that now, are you able to find probability of X equal to 0 by using the formula? Remember how the formula? So X follows a binomial distribution with 4 and 0.5 as the N and P. Okay, if you want to find X equals to 0, then we use NCL first. So there are 4 times you're going to repeat this experiment 4 times, so it should be 4 first. 4C, and you want 0 times success, so you put 0 here. And then you're going to put probability of success. You have to consider probability of success. How many times? 0 times. Then what about probability of failure? 1 minus probability of success. And then how many times failure? So you may consider 4 minus 0. The total number of times is 4, and then you minus the number of success, so it is the number of failure. Okay? So this is the binomial formula. And then you will find that it is equal to 0.0625. And then what about probability of X equal to 1? First of all, 4C1. Probability of success, because you want 1 times success, so 0.5 to the power of 1. And then probability of failure is 4 minus 1, which is 3. So this is the probability. And then if you continue, you can find all these probabilities. Okay? So, and then you may tell people how does the probability distributed. You may use a formula. This is the formula. You may use a table, or you may use a graph. Let's use a table. So I've just found this probability so that I could use the table to represent the probability distribution. So it distributed like this. So from small to 0.3, and then go back to 0.2, and then 0.06 something. Okay, it's like a bell shape. Now, with the probability distribution, so there are 2 things that we always concern about a probability, which is the expected value. Do you remember how to find the expected value? To find expected value of X, we use each of the value of X times the corresponding probability, and then pass the second pair, pass the third pair, the fourth pair, and the last pair. And then you add them up, so that in this case, you find that the expected value of 2. Then what about the variance? Do you remember how to find the variance? First of all, before you find the variance, you have to find expected value of X squared first. So each of the value of X, you consider square. So 0 squared times the corresponding probability plus 1 squared times 0.25 plus 2 squared times 0.375, and then 3 squared times 0.25, and the last one squared times 0.0625, and then you will find that it is equal to 5. So now with these 2 information, you may go ahead to find the variance. The variance of X is just, according to the formula, is expected value of X squared minus the square of expected value of X. So 5 minus 2 squared, so that you could find that the variance is 1. Okay? But you may find that, oh, this is so time consuming, so many calculations to do. Is there any shortcut? Yes, there's a shortcut. You may also put it this way. Because we have, for binomial distribution, we have this formula. For whatever random variable follows a binomial distribution with parameters n and p, the expected value could be found by just n times p. P, just times them together. And the variance is n times p times 1 minus p. So let's try. In this case, we have 4 and 0.5 as the parameters. So np, so 4 times 0.5 become 2. Yes, the same. And the variance is np times 1 minus p. So n times p, 4 times 0.5 times 1 minus 0.5, which will become 1. Yes, it's the same. So it confirms with our result. Therefore, now you may be confident enough to use this formula, np and np times 1 minus p. This is the way to find expected value and variance in that binomial distribution. And for the proof, because it is very advanced, the proof, we do not need to learn the proof in this syllabus. So you may learn this proof in university if you study statistics. All right, just memorize this result. This is the binomial distribution. Okay? And now I would like to go back to this book. So there are some examples on this textbook I would like to go through with you together. So first of all, this example, can you see? Focus. All right. So you see that X follows, oh, B, what does it mean B? Now in the school book they use B, but I prefer to use BIN because it is, if you use B, it's very confusing. I don't know whether you're talking about a Bernoulli or binomial. Although there are two parameters, it should be binomial, but I prefer to use BIN because this is what I learned in my old days. I use BIN instead of B. It's up to you, you could use B or BIN. Okay? X follows a binomial distribution with number of experiment 25 times, and for each of the time, the probability of success is 0.2, and you have to find these two probabilities. So X follows binomial 25 and 0.2 as the parameters. And first of all, you have to find the probability of X equal to 3. So do you remember the formula? So first of all, what's C what? Yes, we're going to repeat this experiment 25 times, and we hope that to have 3 times success. And that means 0.2, the probability of success, how many times? 3 times. Then what about the probability of failure? 1 minus 0.2, how many times failure? Yes, the totally there are 25 times. We want 3 times success. That means 22 times failure. Okay, 25 minus 3. So this is what? This is 0.1358. Correct to 4 decimal place. dp. Okay? And then part B. Oh, you have to find the probability of X. You have to find the probability of X in between 9 and 6. That means what could X be? X could be equal to 7. And also X could be equal to 8. So you have to find these two probabilities. For X equal to 7, we need 25C7 probability of success. How many times? 7. Probability of failure. 25 minus 7 becomes 18. Okay? And then probability of X equal to 8. What's the what? 25C8. Probability of success. 8 times probability of failure. 25 minus 8 becomes, what is that? 17. Yes, 17. Okay? And then The result is 0.1732. 1732. Also, this is corrected to 4dp. Okay. So this is how we use the formula, the binomial formula, to find the probability. And now let's go to the second example. Let's look at this one. Look at this. A fair coin, it is a fair coin, so getting a head and getting a tail, the probability are the same, 0.5. It's tossed 10 times. We are going to repeat this stupid thing 10 times. So find the probabilities of the following events happening. First of all, exactly 5 heads are shown. First of all, you have to define the random variable. You may let x follows a binomial distribution because you are going to do this thing 10 times, and for each of the time you concern what? Oh, no. I'm so sorry. Please forget it. I have to define the random variable properly. You have to tell people what does it mean by x. Let x be the number of head obtained when tossing a fair coin. How many times? 10 times. Okay, you have to properly define the random variable. You have to tell people what does it mean by x. And then after that, you have to tell what kind of distribution x follows. In this case, x follows a binomial distribution. You are going to do this thing, tossing a coin 10 times. And for each of the time, getting a head, probability of success is 0.5 because it is a fair coin. Very fair. And now you may try to answer the question, part A. Find exactly 5 heads are shown. Getting 5 heads, that means x equal to 5. Are you able to find this probability? Because it is a binomial distribution, you could use the binomial formula. What C what? 10C5, yes. And then probability of success, 0.5. How many times? 5 times success. And probability of failure, how many times failure? 10 minus 5, 5. Okay? And then part B. Okay, let me peek the answer. 0.2461. 0.2461 corrected to 4TP. Okay. And then part B. At least 8 heads are shown. At least. Be careful. So at least 8 heads. That means x should be more than or equal to 8. At least 8. It could be 9. It could be 10. So that you have to consider x equal to 8. Not only 8 but also 9 and also 10. Can it be 11? No, because you just performed this experiment 10 times. You could get at most 10 heads, but you never can get more than 10 heads. So you have to use the formula 3 times 10C8, 0.5 to the power of 8, failure 2 times, and then 10C9, 0.5 to the power of 9, 1 minus 0.5 to the power of how many? 1. And one more. 10C10, probability of success 10 times, probability of failure 0 times. Okay? And then you will find that the probability is 0.0547, corrected to 4dp. Okay? And then let's look at a complicated example. So Okay. Ready? The probability that a machine produces an unqualified item is 0.2. So for each of the item, the probability of unqualified is 0.2. Suppose each item is produced independently. 3 samples with 5 items each are selected at random from the production line for inspection every day. The quality control team will reject a sample if there are more than 2 unqualified items in it. In addition, the production line will be stopped if 2 or more samples are rejected. So this is a complicated situation. So this is the difficult part in statistics. So calm down and think carefully. First of all, we have to find what? We have to find the probability that a selected sample is rejected. So look at a sample. We are now just looking at one sample. So in one sample, how many items are there? We know that 5 items each are selected. So in each of the sample, there are 5 items. 1, 2, 3, 4, 5. In one sample, there are 5 items. And then the quality control team will reject a sample if there are more than 2 unqualified items. So each of these items, it could be qualified or unqualified. For unqualified, the probability of unqualified for each of the item is 0.2. There are 0.2. The probability for each of the one is unqualified. Okay, so you have to check the sample, and you have to find the probability that a selected sample is rejected. We are going to reject this sample when there are more than 2 unqualified items, so that we are now looking for these 5 items, and then we concern how many of them are unqualified. Okay, so you should now let X, the random variable, be the number of unqualified items amount 5 items. So you have to put it this way, because in each of the sample there are 5 items. So you are going to check one by one, check 5 times. And for each of the items, if it is unqualified, that means success. We want to check how many of them are unqualified. So X be the number of unqualified items among 5 items. Okay? Then we know that X follows a binomial distribution because we're going to check 5 times. And for each of the time, the probability of success being unqualified is 0.2. Okay? So what are we looking for? We have to find the probability that the selected sample is rejected. So we have to find the sample is rejected. You have to find this probability. And if you want to reject the sample, you need how many unqualified items? If there are more than 2 unqualified items, then you reject the sample. That means that if you want to reject the sample, you want X to be more than 2. When there are more than 2 unqualified items, then you reject the sample. Okay? For X is bigger than 2, that means what could X be? X equal to 3, X equal to 4, or X equal to 5. You have to find 3 probabilities. So remember the formula? You're going to check 5 times. We want 3 times success. The probability of success unqualified is 0.2, so you need 3. 0.8 is 2. The second one, 5, C4, 0.2 to the power of 4, 0.8 to the power of 1. The last one, 5, C5, 0.2 to the power of 0, 0.8 to the power of, how many? No. 5, and then 0. 5, 6, 0, 8. Okay? So that you will find that it is equal to, what is that? 0.0572, and then you have to, after that you have to give your answer in 4 dp, so that you have to write 0.0579. So this is correct to 4 dp. Okay. And then next, find the probability that the production line is stopped in 1 day. When do we stop the production line? The production line will be stopped if 2 or more samples are rejected. So how many samples are we going to check? We are going to check 3 samples. And for each of the sample being rejected, the probability is 0.0579. This is the probability for each of the sample being rejected. Therefore, now we are looking at 1 sample, 2 sample, and 3 samples. 3 samples. We are going to look at 3 samples. And for each of the sample, the probability of reject. So the probability of being rejected, we have just find this probability, 0.0579. But we do not use this value. We have to use the previous one, a more accurate one. Because if you are going to use 4 dp, then the final result will not be corrected to 4 dp. You have to use the previous one, so that we have to use 0.05792. Okay, so now you are going to look at just 3 samples, and for each of the sample, the probability of being rejected is 0.05792. Okay, so that you have to let another random variable. Let y be the number of sample rejected among 3 samples. You're going to check the samples, this sample one by one, and then when it is rejected, it means success. So this is y, not x. You have to define another random variable. And then y will follow also a binomial distribution, and now you're going to check 3 times. So 3. The probability for each of them being rejected is 0.05792, what we find in part A. This time you are not looking at each of the sample, but you are going to look at 3 different samples. For each of the sample being rejected, success is this. This is the probability. So you have to find what? You have to find the probability that the production line is stopped. When do we stop the production line? The production line will be stopped when 2 or more samples are rejected. So we want y be more than or equal to 2. When they are more than, or 2 or more, yes. When there is 2 or more samples rejected, then we stop the whole production line. So that it means that you have to consider y equals to 2 and y equals to 3. Okay? So when y equals to 2, use what C what? We're going to perform this experiment 3 times, and we need 2 times success. So the probability of success, 0.05792 to the power of 2. The probability of failure, 1 minus 0.05792 to the power of 1. And then pass. Oh, I'm so sorry, I did not prepare enough blank paper, so it's just like a mess now. Pass. The second part, what about y equals to 3? C3, probability of success 3 times, probability of failure 0 times. So add the two probabilities up. So here, like here, add the two probabilities up, then we have this probability. The probability of there are more than or equal to 2 samples being rejected, then we just stop the production line, stop the factory, not producing anything else more. Okay? And then don't forget that we have also learned how to find the mean and variance of binomial distribution. So to find the mean, just use n times p. To find the variance is n times p times 1 minus p. So this example, look at this. We have two different random variables. X follows binomial distribution 12, 0.3, and y follows also binomial distribution 20 and 0.8. So find the mean and variance of x, very simple. Find the mean and variance of x. First of all, mean, just n times p. So 12 times 0.3, 3.6. And then find the variance, n times p times 1 minus p. 12 times 0.3 times 1 minus 0.3, which is 0.7, so that we have 2.52. And then likewise, you have to find mean and variance of y. So n times p will become 16. And then for y, we have n equals to 20, p equals to 0.8. So n times p times 1 minus p, we have 3.2. Okay, and then finally, you have which distribution is more dispersed. So how to know which one is more dispersed? It depends on the variance. The bigger the variance, the more the dispersed it is. So you just need to compare 2.52 and 3.2. Obviously 3.2 is bigger than 2.52. So the distribution of y, variance of y is bigger than variance of x, so y is more dispersed. Okay? So today we have learned 3 things. First of all, binomial distribution. The formula for binomial distribution, the symbol, the notation of binomial distribution, and also how to find mean and variance of a binomial distribution. So please do this exercise. Homework B. Okay? I understand that for this, starting from this chapter, this part, you have more questions. So let me know which question you have difficulties, and I will make more videos to elaborate, to explain more properly. Okay? So don't be lazy. Work hard. Bye-bye.